तोड़ूं ताकि जो पॉइंट जो हिस्सा मैं सिलेक्ट कर रहा हूँ स्टिक का, ठीक है, उसमें भी ये पॉइंट भी मौजूद हो, ठीक है. सो दिस इज व्हाट सो काइंड ऑफ एक्सपेक्टेड लेंथ LENGT एट लेंथ मालूम करनी है ऑफ पीस, उस पीस की दैट कंटेंस पॉइंट P, ठीक है. फॉर एग्जांपल इस पॉइंट P को मैं नाम दे देता हूँ P का, ठीक है. Just give that point P a name. So let me introduce a random variable. फर्ज करें LP लेंथ है उस हिस्से की. So LP is the length of that part of the stick that contains P point. So LP अब फंक्शन होगा ऑब्वियसली U का, ठीक है. तो अब मैं कहूंगा LP ये बराबर होगा किसके, 1 माइनस U के, कि अगर U स्मॉलर से पहले हो, यानी आप जो ब्रेक कर रहे हैं पार्ट को वो P से पहले ब्रेक कर रहे हैं, तो फिर U किस हिस्से में लाई करेगा, 1 माइनस U में लाई करेगा. और यानी उसकी लेंथ यानी लेंथ जो है उस हिस्से की दैट कंटेंस P इज गोइंग टू बी 1 माइनस U के अगर U स्मॉलर हो P से. और अगर U ग्रेटर हो P से, यानी पॉइंट P ये है जबकि जहां आप स्नैप कर रहे हैं जिस हिस्से को आप U कह रहे हैं, ठीक है, लाइक ऑल दिस पार्ट, तो आप कहेंगे जी इसकी लेंथ होगी U, यानी वो हिस्सा कि जो कंटेन करता है पॉइंट P उसकी लेंथ होगी U के अगर U इज बिगर देन P. So the answer that we have been asked is to compute the expected length of the part of the stick that contains the point P actually. So this is what that we would like to know, ठीक है. So this is like we have a function of random variable U, ठीक है, और हमें उस फंक्शन रैंडम वेरिएबल की हमें क्या करनी है, ये एक्सपेक्टेशन कंप्यूट करनी. अच्छा, U की क्या डिस्ट्रीब्यूशन होगी अगर आप वार करें. U is basically uniformly distributed. इसका मतलब ये है कि I can break this stick from at any point, ठीक है, यानी कि मैं रैंडमली एक पॉइंट सिलेक्ट करके ब्रेक करूंगा, ठीक है, सारे पॉइंट्स सिलेक्ट होने के चांसेस जो हैं वो एक ही जितने, ठीक है. सो नन ऑफ अ पॉइंट हैज अ मोर प्रेफरेंस देन अदर, यानी मैंने स्टिक ली और स्टिक का एक पॉइंट चूज किया और उसे ब्रेक किया, उस पॉइंट दैट पॉइंट इज रैंडम एक्चुअली, बट दैट उस पॉइंट के चूज होने की प्रोबेबिलिटी किसी दूसरे पॉइंट की चूज होने की प्रोबेबिलिटी के बराबर है. सो इट्स रियली द व्हाट वी कॉल यूनिफॉर्मली डिस्ट्रीब्यूटेड. वी विल टॉक मोर अबाउट यूनिफॉर्म distribution in a minute actually. So let's compute the expectation of P. So the expectation of LP of U is going to be that यदि आप integrate करें from 0 to 1 is LP of U du, ठीक है. और we know that if you are से अगर आपका U जो है between 0 to P हो तो फिर LP of U की क्या वैल्यू होगी, यानी इसका मतलब है कि P U is smaller than P because U is in the interval 0 to P. इसका मतलब है कि U is smaller than P, so it's going to be 1 minus U du 1 minus U du plus अगर आपका PU between say P to 1 है, then this is going to be U actually. So you can easily solve this integral. So once you will solve this integral, it's going to be 1/2 plus P times 1 minus P. ठीक है. So this is really the expected length of that part of expected length of that part of stick that contains the point P. ठीक है. By the way, ये जो length है, यानी ये जो expected length है, maximum कब होगी? So if you want to, for example, find that U या that P, यानी इस point को कौन सा हम select करें, so that कि ये length maximum हो, ठीक है? So how can you compute this? You know, for example, maximum length. So this is like you take this function, like you take f of x equal to 1 over 2 x 1 minus 1 over 2 plus x 1 minus x, and try to find the maximum of it. So you will see that this expected length is going to be maximum कि जब p 1/2 हो. यानी अगर आपका ये जो randomly chosen point है जितना middle के करीब होगा तो expected length उस पार्ट की मैक्सिमम होगी कि जो पार्ट बी को कंटेन करता है. ठीक है. So I hope you got some sense of this interesting problem actually. Okay, so there are more such problems you can find it in a book, and you can read it basically. For more details you can read from the book. ठीक है. Okay, so in case of there's a proposition. In case of we have seen actually, in case of discrete time random variable, expectation has some properties. For example, one property was that the expectation of ax plus b is equal to a times of expectation of x plus b. So expectation kind of behaves like a linear problem. जबकि variance जो थी, the variance of x was expectation of x square minus expectation of x whole square. So this was the variance of it. Or the third property, for example, for the variance was that the variance of ax plus b is really equal to a ka square times variance of x plus the variance of the constant is 0 actually, it doesn't contribute anything into it. So we proved these identities for the case of the discrete time random variable. The question is, are these also true for the continuous time random variable? The answer is yes actually. They do are, they do are true. For example, एक छोटा सा, let me prove this. For example, function expectation of ax plus b. ठीक है. So now this expression is like the function of x. So let's call it g of x actually. So this is like g of x. और हमने पढ़ा कि expectation of g of x is what? That you integrate from minus infinity to infinity what? G of x यानी ax plus b multiplied by the PDF of x, let's call it fx of x dx. ठीक है. And now you can simplify this integral. I can break this down to this integral. I can say that this a is a constant, so I can pull it out. So I'm going to have 8 minus infinity to infinity x f x of x dx plus b. B is like a constant, I can pull it out, minus infinity to infinity fx of x dx. Okay, you're going to have this. Now I'm integrating here a PDF from minus infinity to infinity. So by integrating a PDF from minus infinity to infinity, you get what? So this quantity is 1. While this quantity by definition is expectation. So this is expectation. So what did you got? A multiplied by expectation plus B multiplied by 1, so you have it actually. ठीक है? Try to prove these two identities for yourself. So try to prove these two identities for yourself. So in other words, the properties that you saw in case of what do you call? In case of the discrete random variables, they are also true for continuous time random variables. ठीक है जी? So let's move to now, after doing this a little bit of theory of continuous time random variable, let's now move to the applications of these continuous time random variables actually. And let's try to have some examples, some interesting examples of continuous time random variables. So the first kind of example that we're going to have is what do you call the uniform random variable. Random variable. So the first example that I would like to talk about is really uniform. Okay. So what is uniform random variable? So for example, you think of the discrete time random variable, take a case, and you see that you roll a die, आप एक die roll करते हैं. So what could the possible outcomes can come? So 1, 2, 3, 4, 5, and 6. So these are the values of x actually. Or for example, this is the probabilities of x. Okay. So if I plot this, what you're gonna get? In this, all 6 parts have an equal chance of appearing actually. ठीक है? अगर आपका die जो है वो fair है. So if your dice is fair, then any one of these 6 can appear actually. And each one of them is going to have an equal probability. Like, 1 की कितनी है probability? For example, if this number represents 1/6, then 1 has a 1/6 probability of being appearing. 2 का भी 1/6 है, 3 की भी 1/6 है, 4 की भी 1/6 है, 5 की भी 1/6 है, 6 की भी 1/6 है. So this is really what you call the graph of the PDF of a random variable in which all outcomes are equally likely. Okay? Equally likely. So this is equally likely situation. The question is, what would be the continuous time analog of equally likely situation? Okay? For example, so I can have, so imagine you are waiting for a bus actually. We'll do one practical example of it. So imagine you are waiting for a bus. Okay? And you know that the bus comes say between say 5 to 10 minutes. ठीक है? 5 से 10 मिनट के दरमियान जो है, the bus will appear. The question is, okay, in 5 और 10 के दरमियान ये जितने भी seconds हैं या minutes हैं, इनमें से हर एक यानी बस के इनमें से किसी भी instant पे आने के क्या chances हैं? तो मैं कहूँगा they all are equally likely. The bus can come at any instant between 5 to 10. ठीक है? Bus can come at any instant between, what do you call, 5 to 10. ठीक है? अच्छा, और वो अच्छा यहाँ हमें कैसे पता चला था that every single outcome has a 1/6 chance of being selected? ये 1/6 कहाँ से आया? तो 1/6 ऐसे आया कि ओके, आपने कहा जी टोटल नंबर ऑफ आउटकम्स कितने हैं, 1 को डिवाइड कर दें उस टोटल नंबर ऑफ आउटकम्स से, तो आपको इनमें से हर एक पॉइंट की प्रोबेबिलिटी जो है वो मिल जाएगी इफ दे आर इक्वली लाइकली. सवाल ये है कि अगर बस 5 और 10 के दरमियान मिनट्स के दरमियान आनी है और 5 मिनट से लेकर और 10 मिनट तक, ठीक है, 5 से यानी 2:05 और 2:10 के दरमियान जितने भी इंस्टेंट्स हैं उन सब की इक्वली लाइकली, यानी बस के उन सब इंस्टेंट्स में आने के चांसेस जो हैं वो इक्वल हैं। अगर उनके चांसेस इक्वल हैं तो क्या हम गैस कर सकते हैं कि वो क्या होने चाहिए? जैसे यहाँ पर क्या था कि जैसे ये टोटल आउटकम्स कितने हैं, 1 को डिवाइड कर दें उन टोटल नंबर ऑफ आउटकम्स में से तो फिर हर एक की प्रोबेबिलिटी मिल गई। मगर यहाँ इंस्टेंट्स कितनी है? इंस्टेंट्स तो इन्फिनिट है, there are infinite instants actually. So what would be the best way? The best way, would be to take the length of the interval, यानी ये कितना longer है interval, and divide it by the 1 actually. So 5 से लेकर 10 मिनट तक के बीच बस के किसी भी इंस्टेंट पर आने की प्रोबेबिलिटी क्या है? 1 डिवाइडेड बाय द लेंथ ऑफ द इंटरवल, यानी 10 - 5. So instead of counting instants, which we can't, just think about what do you call the length of the interval. So 1/10 - 5, so it's going to be 1/5. So I would say अगर ये x और ये p of x है, यानी probability of x है, so the probability has this graph actually, if this point is 1/5. ठीक है? So uniform distribution in a simple language is a continuous time analog of discrete time में जो हम equally likely events लेते थे, ठीक है? So उसका continuous analog है, ठीक है जी? So with this intuition, let me define uniform distribution in a rigorous way. And let's talk about some of the parts of it. Some property of it. Uniform random variable. Okay. I would say x एक random is a variable, so it is uniformly distributed. ठीक है? So the notation that I am going to use is U stands for uniformly distributed in the interval a to b actually, where a and b is like the instants 5 and 10 actually. ठीक है? So how I would read it. So I would say x is uniformly distributed over interval a to b. A to b could be a closed interval, open interval, semi-infinite, semi-closed interval, whatever. ठीक है? Now call it an open interval actually. Interval if its PDF, अगर उसका जो PDF हो, can be given as fx of x. Fx of x का represent करता है what is the probability that x will take value x. In other words, अगर x आपके waiting time को represent कर रहा है, तो what is the probability that x, that is an instant between a to b, ठीक है? What is the probability that x will take value x? So this is equal to 1 over, जैसे वहाँ हमने किया, the total length of the intervals is going to be b minus a. ठीक है? So if x is uniformly distributed over interval a to b, तो समझ जाए कि इसका PDF ये होगा. And otherwise, इसके अलावा हर जगह यानी a से नेगेटिव इन्फिनिटी और b से पॉजिटिव इन्फिनिटी पर दिस रैंडम वेरिएबल इज 0. ठीक है, यूनिफॉर्म डिस्ट्रीब्यूशन. वेरीफाई करें, आपने खुद वेरीफाई करना है कि fx of x is indeed a PDF. ये वाकई PDF है. ठीक है, और PDF कैसे वेरीफाई करेंगे जी? इंटीग्रेट करें फ्रॉम माइनस टू इन्फिनिटी दिस fx of x dx को and see whether you get 1 or 1. So we'll see that you're going to get 1 for sure. So what would be the interesting things about this probability? So for example, अगर मैं ये कहता हूँ कि जी चलें, let C and D दो instants हैं in the interval A to B, ठीक है, such that C is smaller than D, for example. तो इसका expression क्या होगा? What is the probability that X is between, for example, C to D? So how are you going to compute it? C to D. So what would be that? So you can easily compute it. So there can be many ways. For example, one way could be that if you take the CDF of the uniform distribution fx of and compute it at D and subtract it from C. So this is one of the things that you can do. The other way could be that okay, आप PDF ले लें, यानी fx of x ले लें dx and integrate it from C to D. ठीक है? And you're going to get a probability. So it's going to be what? So fx of x is 1 over b minus a. So 1 over b minus a is like a constant, so you can pull it out of integral. So the outcome is going to be the integral c to d dx. So it's going to be d minus c over b minus a. So this is what it is going to be. ठीक है, चलिए CDF अगर हम देखें, what is the CDF of uniform distribution? So for that, what we need to do is that we need to compute what is the probability x is less than or equal to what do you call x. Okay. So you have to compute this. So how you can compute it? Okay, integrate from minus infinity to x. Imagine that x is in the interval a to b. fx of x dx. ठीक है, x फर्स्ट कर दें that के लिए इंटरवल a to d में है. अगर x यहाँ इस्तेमाल किया है तो यहाँ कोई और वेरिएबल इस्तेमाल करें. ठीक है, but you know this PDF, its PDF only exists in the interval a to b. So I can restrict. So this is like this picture actually. So a is here, b is here, and x is somewhere here, and you have an integral from minus infinity to x. Okay, but I know that my function, the PDF here is 0, while it only exists here actually. So I can say that this integral is going to be a to x, and 1 over b minus a dx dt. So simplifying is going to give me x minus a over b minus a. So this is what is going to be the CDF of the uniform distribution. And similarly, you can compute the expectation and the variance of it. So let's compute, say, the expectation of the uniform distribution. As in case of discrete time random variables, you know, equally likely probability was good, but not good enough actually, you know. Usually things do not have equally likely chances of being, what do you call, selected actually. So there is always a bias, there is always, you know, something hidden. Okay, so the uniform distribution is good. Okay, and it's good from practically, you know, from a practical point of view, because if you want to implement, all these things into say for example into a programming language, and you want computer to compute these all probabilities for you, then what happens typically is that almost all kind of distributions that you're going to learn in the future can be expressed in the terms of the uniform distribution actually. So this is what makes uniform distribution a useful tool, okay? Though practically it's not it's not that good kind of approximation, but for a computational point of view, uniform distribution is very useful. So let's compute the expectation of x. So I can compute the expectation of x by computing from minus infinity to infinity this x, fx of x dx, but I know that this guy only exists between a to b, and x over b minus a dx. So this x will become b minus a, okay, and times the integral is going to be x squared by 2 a to b, and simplify b squared minus a squared, and simplify, you're going to get a plus b upon 2, and this meets with our really intuition actually. So think about it. So expectation is like the middle of the data. So if you have the interval a to b, where is going to be the middle? The middle is going to be right at this point, the a plus b upon 2. So it meets with our intuition as well actually. Okay? So compute the variance of random variable x, variance of x for yourself. I'm just mentioning it. So it turns out to be b minus a chi square by 12 actually. So this is what is really the variance of the expectation of x. Let's do one example on uniform distribution, and then move to the next distribution actually, the more important one. So here's an example. So this is an example from Ross. So this example is example 3C. So what does example say? So example says that imagine you are at a bus stop. Okay. So this is a bus stop on a road. Okay. So this is a bus stop on a road. And imagine someone is waiting at this bus stop to arrive the bus actually. Now if you look at the schedule of the bus, what happens is that the bus comes after every 15 minutes actually. So what do you mean by that? So it comes at, say, in an hour, ठीक है, 1 घंटा start होते हुए, for example, it comes at say 0 minutes, in other words 1 बजे आएगी, 10 बजे आएगी, then it's going to come after the 15 minutes, it's going to come after the 30, again next 15 minutes, is going to come again after the 45 minutes, and again 0. ठीक है? यानी for example, if I say that, ये बस जो है, if you are talking about 7 बजे के टाइम की बात कर रहे हैं, तो बस जो है या तो 7 पर आएगी, या 7:15 पर आएगी, या 7:30 पर आएगी, या 7:45 पर आएगी, या फिर 8 बजे आएगी, and so on. ठीक है? So it comes after every 15 minutes. ठीक है? So here's the thing. So a passenger arrives at a stop. So there's a passenger that arrives at this stop. ठीक है? between at any instant between 7 to 7:30. ठीक है, यानी the passenger comes onto the bus stop at any instant between 7 to 7:30. So by any I mean it's like uniformly distributed actually. यानी इस 30 मिनट के टाइम पीरियड में 7 से 7:30 के दरमियान फर्ज कर दें this person arrives at any instant. ठीक है.